Good morning, friends. Today we are studying what is the concept of divide and conquer method, merge sort, and quick sort. Then what is overview? Here we are studying divide and conquer, as I discussed, and the concept of divide and conquer in merge sort, and concept of divide and conquer in quick sort. Then what is the divide and conquer? Then first we will discuss what is the base condition in divide and conquer. If I have only single element that is small enough, then there is no need to divide the problem because single element is there. So we will solve it directly. This is the base condition. If I have more than one element, then what will happen? Then we will divide the problem into smaller or similar part. Then we recursively solve those subproblems and combine the solution to the subproblem. This is the concept of divide and conquer. When we will study in sorting only, then what is the concept in sorting? Our input is when we are talking about if I have array A, which left linear bound is left and upper bound is right, then unsorted array of integers, then output, what will be the output? The sorted array is our output. What is the concept of divide and conquer? If we are talking about base condition, then what is the base condition in sorting? Then if I have left is greater than or equals to right, means left and right is on same position, then this is the condition of single element. Then we will return over here. If this is not happening, then what is going to divide? We are taking two parts, maybe it from left to middle or middle plus one to end, it may be. Then we divide it into two subproblems, sort first part and second part, and solve it. Recursively sort first part, second part, and combine the sort first and second part. Then we will take output of sorted array. When we use in merge sort, then what is the meaning of merge sort over here? Then what is the idea of merge sort? That we have more than one element, then first divide the first list, second list, recursively sort first part, second part, and merge those lists into single list. What is the algorithm of merge sort? If we are talking about merge sort a left to right, then what is base condition? If left is greater than or equals to right, then this is the base condition. Then we will return. If else, first we calculate middle over here, left plus right by 2, where left and right both are lower bound upper bound values respectively. Then what will happen? Solve first, recursively solve first part. What is merge sort? A left to middle and a middle plus one to right. This is second recursive. Then we will call the merge, which merge to both the list, sorted list. Then what is the concept of merging? Merging means if I have two sorted lists, first part is here we are seeing that a left to a middle and a middle plus one to a right. If I have two sorted lists over here, which is indicated by different colors, green color represent first sorted list and red color represents second sorted list. Then what is the meaning of sort merging? When I have a combined list of both colors, means red and green, that indicates that sorted list is there. We are taking one example over here. If I have sorted list 2 to 8 and 1 to 6, two sorted green color represent first sorted list and red color represents second sorted list, and we are taking it in temporary variable, then what is the concept of merging? Then we are taking three pointers I, j, and k. Here we are saying that. Then compare I to j, which element is small. Then it took it in temporary variable and increase to that variable pointer. This. We compare first element. What is the I equals to 0, 2 to 1. Which element will there? Then 1 will there, because this is a small element. Then increase the value of j as well as k. Then again compare the value of I and k. Here 2 and 4, which element will be there? Then 2 will be there. Then just put value of 2 and increase this time I pointer value and k pointer value. Again, we will compare I and j. Then 3 will be there and increase the value of I. Here j value will be there. Then increase the value of j. Compare 5 to 7. Again j value will increase. Then compare with 6 to 7. Again j value will be increased. What will happen here? If j is completed, then select all the values of I and just copy and paste this value at temporary variable k, this type 7 and 8. Here no comparison will be there, only copy to those elements if a list is not completed. Here we are taking the example. This is the algorithm. This algorithm merge a left, middle and right. We are just seeing this algorithm. A left to right is global array containing two sorted lists, a left to middle, a middle plus 1 2, and temporary variable is an arbitrary array which take the value of sorted array. Then we will copy this temporary array into normal array. Then here we are seeing that there is two while loop is there. First, I is less than or equals to mid. If I completed to middle, then copy the value of j. If j is up to end, then copy the value of middle up to last value, up to middle value. If here we are saying that if we are comparing a of I to a of j, which element will be small, then took this value temporary k and ai and increase the value of ai. Otherwise, else put the value of j into temporary variable and increase the value of j. This type loop is working. If first element middle is completed, then copy the value of j to end to temporary variable. Otherwise, copy the value of I to middle at temporary variable. Here we are seeing and increase the value of k in both the cases. At last, what will here copy all the data from temporary array to a. It means the sorted list is in temporary array. This time we are copying all the temporary values in the original array a. This type the merging concept here. What is the concept of what is the space complexity here? Then order of n is the space complexity and the time complexity is n for merging only. Then we are seeing an example of merge sort. Here we are taking an array which have 8 values. A 0 indicates first linear bound value, which is 6, and 7 indicates the last upper bound value, which is 1. Then I have a single array 6 2 8 4 3 7 5 and 1. Then just how this algorithm works, we are seeing that first divide the value, means calculate the middle value. What is the middle element? 0 plus 7 by 2, that is 3.5. Then our value is divided into 0 to 3. First we call if from a 0 to left to middle, then what is the value of middle is 3. Then merge sort is calling a0 up to a03. Here a03 is 6 to 8 4. Then again call, then divide the list. First again divide the values. This happened with is 101 62. Then again divide. This happened if left is greater than or equals to 0. Here left and right is 0 0. This is the base condition. Then return the value. Just again 2. This is also base value. Then return. Here I have two lists 6 and 2. Then merge is called. Then merge call is there. Then it divided this list 6 to 2 2 6. Then return the value 2 6. Again calculate the value for 8 4. Then divide the list. Merge sort is calling. Again divide the list 8. Then value will return 8. Value will return 4. Then merging is calling. Again return the value. Then here we are also called merge, which merge 2 6 and 4 8 as we seen earlier. Then what will happen? This returns and merge array. This array is returned to here. Similar thing is happened at other half part, that will divide this thing and divide the values, up to base condition and return the value. Again return the value. Then we have two array, 1 2 to 8 and one again other is 1 to 7. Then we will merge those value. Then our answer is generated, sorted array. This is done by sorting. What is the analysis, merge analysis? When we are talking about the sorting analysis, then I have divided the list n into n by 2 part and n by 4 part up to base condition. Then there are log n levels over there. Then the total time complexity, where we are just discussing that n number of comparisons is there at log n levels. Then the complexity is n log n, the total running time complexity, order of n log n, and the total space, because we are using temporary array for storing the sorted array. Then the time complexity is order of n. Merge sort is best time complexity is order of n log n, but it is external sorting because it take order of n space from memory. This is the concept of merge sort. We will discuss that this is the summary of merge sort, the time complexity and space complexity. We will discuss quick sort in next lecture. Thank you. Thank you for watching.